Good morning, afternoon, and evening, everyone. Thanks for joining us for another Cassandra Lunch. I'm going to go ahead and just breeze through a couple housekeeping items, and then I'll hand it over to our speaker this afternoon, Obi. He's going to be going over migrating relational data to YugabyteDB using Yugabyte Voyager. So let's go ahead and get started. The organizers for this event are Rahul and myself. We are looking for speakers and sponsors for this event. If you're interested in either opportunity, please reach out to me at the email listed below. We are a part of a larger community called Data Community DC, which believes in building an inclusive environment. So no matter your race, gender, or sexual orientation, everyone is welcome, and we expect respect to be given to all. Data Community DC is made up of a lot of different groups, generally all surrounding data. You can find out more about these groups at the links listed below. So what do we cover here at Cassandra? We cover everything related to Cassandra, Spark, Kafka. And if it's your first time joining our lunch, we are interested in creating a community here. So please introduce yourself, how you heard about the lunch, and hopefully what you're trying to learn. Group rules: if you have a question, ask it. Please be polite and courteous to others, like I mentioned earlier. And obviously, we want you to share what you know with us. Here at Anant, we design, build, and manage global real-time data and analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. Thanks to our program sponsors, our organizational sponsors, all listed below. And then very quickly, if you have any jobs, meetups, hackathons, conferences, classes, any announcements at all, please leave them below in the chat, along with the link if possible. And then a few upcoming events. We were recently speaking at SlideShare Summit. If you weren't able to attend, please visit their website for replays of the video. We'll have some on our social media as well. We spoke at the event. There were over 30 speakers. We'd like to point you there and check out that as well. Obviously, we have our Cassandra lunch every Thursday at noon and our data engineers lunch every Monday at the same time. Cassandra lunch videos, if you haven't subscribed to the channel already, please do. We have a lot of Cassandra videos, a lot of data engineer videos, a lot of resources for you there. Also like to point you to Cassandra.Link, your one-stop shop for all things Cassandra related. And then finally, our latest Cassandra runbook is out. This edition has some insights on updating Cassandra settings, Yugabyte basics, and snapshots. And with that, I'll hand it over to our speaker for today, Obi. Over to you, Obi.
All right, thanks, Akwi. All right. So as you heard, I'm Obioma Anomnachi. I'm an engineer with Anant. Today's topic is going to be migrating relational data to Yugabyte using Yugabyte Voyager. We gave a talk a little while back about migrating Cassandra data to Yugabyte. And this is sort of a companion to that. All right, so talking about Yugabyte Voyager. Yugabyte Voyager's data migration engine moves data from a number of relational databases, specifically Postgres, Oracle, and MySQL, as well as cloud offerings for those three, into Yugabyte Local, Yugabyte Anywhere, or Yugabyte Managed. So if your Yugabyte is in the cloud or if you're running it on premise, you can move your data using Voyager. It's the same steps regardless of which database you're moving from and which version of Yugabyte you're moving to. It's free and open source and is written in Go. But if you look at the GitHub repo and look at the language breakdown, you'll see most of the lines of code there are actually SQL test data, which is a little bit funny. Okay, so what are the features of Yugabyte Voyager? So it's optimized for distributed databases. When you download the source files, it stores them in chunks, scales and auto-tunes your migration based on the size of your cluster. In fact, not just based on the size of your cluster, but that's something we'll talk about a little bit later. Number of connections based on your target configuration, parallelism across tables and within tables, which means that your source files are not just broken down by table. And basically, it means that your source data is being broken down into pieces because Yugabyte is a distributed system. You don't want to have all your source data in one chunk to be tried to move over at once. Voyager is idempotent. All the individual steps, if you run them, you can run them again without changing the end state of your database. That makes it compatible with something like Airflow, which likes its individual tasks to be idempotent as well. And so it should be relatively easy to schedule and manage in that sense. If your data import is disrupted for any reason, you can resume it. You don't have to start importing all your data again from the beginning. It has progress bars for your data export and import. So this is filling in something that I mentioned a little bit earlier. It scales with your nodes, yes, but it also scales with the CPU on that nodes. So it talks about the default parallelization values for the data import. The default has to do with not just the number of nodes, but the number of cores on on those nodes. So if you have more nodes, you can speed up your migration, but also if you have more stronger, better computers that those are running on, you can speed up your migration as well. This is also a setting you can mess with manually, the parallelization values. And then Voyager also has the ability to directly import your data from CSV files. So rather than having Voyager export data from your source database, if you already have a CSV backup or something, you can potentially use Voyager to import that data. All right, so a Voyager migration is broken down into these steps in these three larger categories of prepare, migrate schema, and migrate data. You don't actually always follow this order, but that's something that we'll talk about a little bit later on and a little bit more in the demo. All right, so what is the preparation phase? You need to prepare your source database, your target database, and the Voyager install itself. So when preparing your source database, mostly what you're doing is, well, one, you have data there that you want to migrate. And there needs to be a user for Yugabyte to use with a username and password that you can feed into Voyager and read access to everything that you want to migrate. And then the target database preparation, you go into Yugabyte, you create the target database. You don't need to create tables or anything like that. Yugabyte can actually transfer that information for you. And you want to create a super user with a username and password that you can feed into Voyager. And then for installing Voyager, you need to install Voyager itself. So whether that's from source, via yum, or apt, what's the Mac one called? Brew. Or the one that we're going to use in the demo is the Docker installation. And this is something that you can also do on air-gapped machines. Yes. And then you need to set up your export directory. It needs to be on the machine, or at least the Voyager install machine has to have access to that disk. It has to be able to hold the entirety of the source database. The way Voyager works is you export your schema and you export all your data, and it sits in a directory until you call the import commands. Well, it sits in that directory permanently. Calling the import commands doesn't actually delete it. But yeah, so you need space on your machine for all the data in the format that Voyager is going to store it, which we'll talk about a little bit during the demo. And that directory contains your schema files and your data files, as well as logs for Voyager itself, reports generated by Voyager, and internal and temporary files specific to Voyager itself. When you are ready to migrate the schema, the first step is to export your schema from your source directory. This saves it to that export directory that we set up in the prepare stage. So for this to work, your PG dump version has to be the same between your source database and your Voyager install location. So this is a problem that I ran into. I used the Postgres 15 Docker container and the Voyager Docker container, and that caused some issues because they don't have the same version of pgdump on them. So you just need to make sure that those are the same. Specifically, especially if you're migrating from Postgres. And then it always stores your schema in PostgreSQL format. Even if you're exporting from Oracle or from MySQL, this store will always be in PostgreSQL format because it needs to be compatible with Yugabyte, which uses that format. And then you run the analyze schema command, which generates you a report concerning the schema's format. So it will tell you how many tables you have, how many indices you have, et cetera, but it will also tell you if any of those things are incompatible with being loaded into Yugabyte. For example, something we're going to run into during the demo is that Yugabyte doesn't support gist indices. It does B-tree and hash, and I believe gen, or at least that's in progress. But just indices, I'm not sure if those are on the roadmap for Yugabyte. And then the next step here is modify schema, but this is actually not something that Voyager does for you. You look at the report, look at the issues section, and then you go in and you fix all of the issues that it tells you about by hand editing DDL files or fixing them in some other way. So this is also what you do. This is also potentially where you would go in and fix some of the, if you're looking at the Yugabyte Voyager page, there's a known issues page that tells you about some of the common issues with Voyager. Like for example, no matter what source database you're exporting from, if your table or index names or something like that has special characters or weird white space or backticks or stuff like that, Voyager will have issues. So this is also the time you might want to go in and fix some of that by, say, renaming your tables in the source database. But basically, once you've modified the schema files or your source database until no more issues are appearing, you can run the import schema command. So the flags that it comes with, we'll go into a little bit more detail during the demo, but there are also these two extra beyond what other Voyager commands have. Ignore exists, which means that if the schema sections, the tables or indices or stuff that you're trying to import already exists, then the Voyager will leave them alone, basically. And then post-import data is something that's clever, actually. We'll go into it in more detail during the demo as well. But basically, the post-import data flag, and this is also one of those ones where you might run commands out of order. It means that your data has already been imported in the bulk import stage. Post-import data comes in and basically makes sure that all of the parts of your schema that might interfere with the performance of loading data are all loaded in afterwards. So if you have a bunch of indices on one table and you try to import your data, every row that gets imported has to update all those indices as well, which would really interfere with the performance of your import data step. So you can come back and run the import schema with the post-import data flag once you've already imported all your data, and Voyager will come in and it will create those indices that it wasn't able to create before, or that it would be disadvantageous to have been created before. And then we come to the migrate data step. So just like you export schema, import schema, now you export data, which is dumped into the same export directory. Like I said, it needs to be big enough to hold all your data. You can specify a subset of a database's tables. But in general, you specify your database, you specify your schema, and then Voyager takes all of the tables and migrates them over, unless you specify otherwise. And then for your import data command, you get to define the parallelism. But like I said, the default has to do with the number of nodes in your Yugabyte cluster and the number of CPU cores that those nodes have access to. And then you can also call import data to load in CSV files that you already have, things that weren't exported via Voyager. And then when you verify in In Voyager, you do that by manually querying both tables and making sure your answers line up. All right. So last time I was here, we talked about a NoSQL migration tool used to migrate data from Cassandra into Yugabyte. So we're going to do a little compare and contrast with that tool. So comparatively, Voyager migrates your table and index definitions, your entire database schema, as well as your data. Whereas the NoSQL migration tool we talked about, it relies on you to set up your schema on your target database, and then it just moves data. That tool that we talked about last time requires a Spark cluster to run on, whereas Voyager doesn't require really anything. You have the Docker container maybe, or you install Voyager on your machine. Voyager migrates multiple tables at once. The NoSQL migration tools that we looked at, they act on one table at a time. You need to call them to migrate one table, and then migrate the next table, and then migrate the next table, and then migrate the next table. Whereas Voyager will take your entire schema and your entire data and export them out to a third location, and then load them in all at once. And then Voyager doesn't have the ability to validate afterwards. So NoSQL migration tools expect to look at your source database, look at your target database, find differences in data in between them, and then like correct them. Whereas Voyager theoretically is meant to be run on a blank target database and move over the entire schema and the entire data. All right, we're going to stop briefly for questions here before we move into the demo. We're going to be looking at migrating data from Postgres into Yugabyte on a Docker container using Voyager. All right, doesn't look there are any questions at the moment. So this is what our data is going to look like. It's an example Postgres database. I just picked it because it had plenty of indices, plenty of foreign keys. So interconnection in its tables that a NoSQL tool wouldn't really have to deal with. So if your data models in SQL and all this complicated stuff like this, it's my opinion that NoSQL tools aren't really set up to handle that kind of thing, especially since NoSQL distributed systems often have trouble with things like foreign keys. They don't support that functionality, whereas Yugabyte specifically does, and therefore needs to be able to migrate it. So it's a DVD rental store, just the entire like payment, staffing, transactions and stuff like that for movies that have people in them, etc. So hopefully this is visible. Okay, so the first thing that we have already done is pull the Voyager Docker container image and set up our system. So this is one node Yugabyte cluster, and then a Docker container with a Postgres database, and that's it. If we all right. And then the next thing that we need to do is set up our export directory for Yugabyte. Just going to call it export dir. And we're also going to export the full file path into a variable, basically because we need to enter it into every Yugabyte Voyager command. They all want to push things or read things from this directory, so they need it as an argument, and it's much easier to just feed it in using this variable. All right, now we're going to set up our source database. First, we are going to put the archive of the data onto that Docker container. And then we're entering into our Postgres container to run some commands. first thing we're going to do, open up PSQL, make sure the database exists. Created the DVD rental. So we can exit here and then use PG restore to load that data in. Open Postgres back up. And now we're going to just take a look at some of this data so we have something to compare it to later. So you see we have all these tables and sequences for those primary keys. So let's look inside the actors table. And then let's also look, I believe the biggest one was payment. We'll get to see the breakdown for these when we analyze the schema later on. So now that we've exited there. Okay, so we have our source database and it has data in it. And I know we just exited the document container as well. But now we are going back in to actually do the setup of the user. So first, create the user. Make sure we're in DVD rental. And now we're giving it access to all of the data that we want to migrate. So these full commands are unnecessary. They grant access to basically everything. We basically just created a super user here. If you are working in an environment that has actual security concerns, you're going to want to dial that down. So you're giving it the minimum access, which is read access to all the data that you want to migrate. And then we are going to go into Yugabyte. So last time that we used Yugabyte for migration, we used the CQL shell, YCQL-SH, but this time we're going into the SQL shell, which is basically the same as PSQL. And the one thing that we actually do need to create here is a database for stuff to go into. And then we also need to create a super user. I'm going to use the same name in both our databases. Okay. And we've made our export directory, but it's currently sitting empty because we haven't run any of our commands. But before we are able to do that, because this is all in Docker, we need to go and grab the IPs to make sure that we're doing this right. So this one is the source DB, which is Postgres. So we need to grab the IP. And then for the Yugabyte, we also need to grab the IP for some later commands. So we've actually done something that we're going to need to go back and correct in the source database in a second, but we will see that when it comes up. So we call our first step export schema. We pass it the export directory, which all of these commands are going to need. We pass it the source database type. We're in PostgreSQL, but the other options for this are Oracle and MySQL. We pass it the IP address or the host name. We pass it the user that we created and the password for that user, and the source DB name that we want to migrate, and the schema that's in. So even though I said there's something wrong with the schema, we're going to export it and it's not going to give us any issues. But then when we hit analyze schema, when you generate your reports like this, they can be in a number of formats. We just chose JSON. Okay, so this is our schema report. It tells us there's one schema. There's types, domains, sequences, tables, indices, functions, aggregates, views, and triggers. And there's an issue with one of the indices. And I mentioned earlier that Yugabyte doesn't support gist as a form of creating indices. And this is a gist index. So while we've already exported our database, we're going to go back into Postgres. Go into the proper database, and we're actually just going to drop that one. So that index would have been here as part of the indices on the film table. And this is another part where one of those like known things about Voyager comes in, especially, well, it comes in not if you're using Postgres, but if you're using, I think it was MySQL, because MySQL allows indices with the same name to exist as long as they're for different tables, and Postgres doesn't allow that, and neither does Yugabyte. So if you're doing that export, Voyager will just append the table name in front. I guess that's prepend in order to make those consistent. So we hit export again. Oh, wait, that was export data. Wrong command. We are re-exporting the schema so that we can once again analyze it. There we go. And now if we run analyze schema, and we look at this report, now issues is null. So if you run analyze schema and it comes back with issues, you either have to go fix them in the source database, or you have to go fix them in the schema definition that's stored in Voyager, which we didn't actually look at yet. Okay, so let's go look at tables. So if we look at our tables, what we see is that all of the create table and alter table commands for those tables are in here. And And then also all the commands for the indices are in a different file. Okay, so now we are ready to export our data since there are no more schema problems. And these progress bars are going to go by pretty fast, but you get progress bars for both your export and import of data. Oh, we didn't really go over what the YB Voyager command is. So you download the image for the Docker container, but there's also a control file, a script essentially that they tell you to download. And what it does is basically a Docker runs the container with the arguments so that it does what it's supposed to do. Failed to connect to. Did I forget to replace the IP address? I did. Okay, so now when we run export command, yeah, so what I was saying is you download this script file, and it will open up the Docker container for all of your actual YB Voyager commands. So we can see we've exported all these tables. There's, a bunch of rows in some of them. Now we can run import schema. Arguments are once again the export directory, but this time we give it the target host, user and password, and database name. You don't really need anything more. And if you'll notice here, what we're getting printed out, it has all of the sequences for the primary keys, all of the create tables and alter table commands, but not all of the indices that were on those tables are actually going to show up here. So it creates functions, aggregates, and views. It's able to run these create unique index commands, but everything else that was in the indexes table, that SQL, is actually getting left out here. And that's because of what we mentioned earlier, where if you have a bunch of indices on all your tables, inserting that data is going to be really slow. So it is, in fact, best to import your data like this first. You're giving it basically the same arguments. And we didn't specify what the parallelism should be, but it's going to use two parallel jobs because we have one Yugabyte node in our cluster that has access to 2 cores. So if we added another node, you get 4 parallel jobs. But also if it had access to more CPU, you could potentially get more parallel jobs by default as well. All right. And then if we go and we look into Yugabyte, we go into the DVD rental, and then we look at the table description for film, we can actually see none of those indices are here. When we ran this command on Postgres earlier, I think it was after. Did we run this command in Yugabyte? Yeah, because we went in and destroyed the gist index somewhere. Here we go. Film primary key is there, but these 2 indices are missing. And that is where we're going to run export schema again, but this time with the post import data flag, meaning that all of the rows of data in the tables have already been imported. And we need to update the schema with all of the indices and stuff that would have affected performance if they were imported before. And remember, the Yugabyte Voyager commands are idempotent. So if you ran Yugabyte Voyager import schema again after post import schema without post import schema, you would get the exact same stuff. But now that you can import schema with post import data, we can create all these indices with minor performance issues. The import of data has already happened, so we won't see issues there. And you can also see there are plenty of other tables that have indices and triggers that would also have been missed during that first import schema that can now be added without issue as well. So the last thing to do will be to go and make sure that our data is actually there. So first, opening up Postgres, going into DVD rental, and doing a query. So we're actually going to modify this query actually because Yugabyte is a distributed system, or just the way queries work in Yugabyte. They won't necessarily give you everything in order if you use limit statements. Well, they won't necessarily give you everything in order, and that means when you use limit statements, you can get different data out. So this is pretty sure it's actor ID. Yeah. So you can see we get our 20 out here. And then also if we look at the payment table, we get data from both of those. And if we go into Yugabyte now, YSQLSH, we can set ourselves up to run the same command we saw earlier, that there was schema here just without the indices, but now those indices actually are here. And when we query data, we can see that we're getting out the exact same data. We successfully migrated all this same stuff. And if we dash the film, we can see that these indices are here. All right, so that's it for the demo. We have one last slide to cover before we're done for the day, but now is another good time to stop for questions. All right, so to finish out, we're going to talk about how could you potentially improve Yugabyte Voyager. So first idea is a real-time migration. Basically, this means modifying it so that rather than storing all of your schema and your data inside a directory on a third machine, this transfers data directly from your source to your target. Because the constraint of having a directory that's going to hold all your data, it limits the size of your migration, basically. as well as potentially making it more expensive. And then CQL support is something that we'd like to see. So we talked about how much of a headache it was transferring data from Cassandra to Yugabyte last time, as a tool like Voyager would really improve that sort of process. Something that would show improvement is a data validation step included in Voyager, something that will check your source against your target once your migration is complete and make sure that there haven't been any errors rather than just leaving that to the user to validate. Some form of automation or scheduling. Currently, you have to run all the Yugabyte Voyager commands by hand, and some sort of automation where these things run one after another, or scheduling where these things run on intervals would be really useful. And then the last potential improvement that we're suggesting is the ability to set up and run Voyager directly inside Yugabyte Managed. So if you already have your Yugabyte in the cloud, you should be able to just click a button in that UI and start being able to migrate data with Voyager. All right, that is it for me today. This is more time for questions. And if not, then I will hand it back to Akwi. Was it inconvenient switching between the CQL and SQL shells? Were there any option for cross-shell search or commands? So I would say that it's not too inconvenient, basically, because if you're looking at the CQL shell, then you want data that's modeled for CQL in that you're setting it up for queries, and it's not going to have things like foreign keys or things like that. And if you're opening your SQL shell, you want a fully realized SQL data model with foreign keys and indices and stuff like that. So if you'll notice in this, like this demo, we were using exclusively the SQL shell. So we were going between the Postgres and the Yugabyte, but when we logged into Yugabyte, it was always via the SQL shell. And then if you watch the last one, we were doing stuff in CQL, moving data from Cassandra. So when we wanted to replicate a query, we had to do that in the SQL shell as well.
Okay, so it doesn't look like we have any other questions. Obi, I want to thank you again for another fantastic talk. I want to thank everybody for joining. Before we head out, I just want to remind everybody, please like the video if you haven't already, and subscribe to the channel as well if you haven't. And I'd like to point you to our new Cassandra, our new runbook that's out. It's not fully focused on Cassandra. Please go download that now. It is free. And then do visit our socials for more information on the RDBMS Summit. We spoke there. There were 30 other speakers there. And we'll see you guys the same time, same place next week. Thanks, everyone. Have a good day.